So in this video, still in section 4.7, we're going to look at another form, which we can always rewrite as the indeterminate 0 over 0 or infinity over infinity. So what is it that we're going to do? So first, remember that in the previous video, we saw how we can rewrite something that looks like 0 times infinity as either 0 over 0 or infinity over infinity. Right? We went over that. In this one, we're going to see the second case. Right? So I said there's three cases we're going to see. Okay, so for this one, let's go ahead and work it out. Go ahead and work it out. So if the limit as x approaches infinity of x minus square root of x squared plus 1. Okay. Now, if we were trying to evaluate this limit directly, like we did in the previous video, we would try to separate the limit, right, and see if everything is defined. And so we would rewrite this as the limit as x approaches infinity of x minus the limit as x approaches infinity of square root of x squared plus 1. Now, what do we get here? Well, the first limit is pretty straightforward. Right? The limit is x approaches infinity of x. We're making x grow larger and larger. This is going to infinity. Minus, now what's happening here? Well, the same thing. You're taking a really large number x, you're squaring it and adding 1. You're taking the square root, so it's going to make it smaller. But the point is, as x becomes larger, this whole expression becomes larger without bound. So this is also going to infinity. Right? So of course, we can't separate the limits when either one is undefined, but the reason why I show you this is because this is the second form we're going to be working with. Something that looks like infinity minus infinity. So it's going to be the second form. So what's going to be the trick when we have infinity minus infinity? Well, it's going to be basically rewrite it as 0 times infinity. Right? That's going to be what we're going to do. Try to get infinity minus infinity to be 0 times infinity. Okay. So how are we going to do that? Well, the process is going to be this. Take, in general, take the term that looks the simplest, right? So we have two terms here. We have x, and we have square root of x squared plus 1. Well, x definitely looks simpler, right? So in general, take the term that looks the simplest and factor it out of the whole thing so that you get a product. So what we're going to do is factor out an x from this term and an x from this term. Okay, so factoring out an x from this first term is easy, right? Just factor out the x. For factoring out an x out of square root of x squared plus 1, you have to do a little bit more work, but it's still doable. So how are we going to do that? Well, I want to get an x out of square root of x squared plus 1. Well, it'd be nice, or the way I could do it is if I had an x squared inside the square root, just being multiplied. Remember, you can separate the square root as long as you have products. So if I had a square root of x squared, I could simplify that to x. Now, square root of x squared is usually square root absolute value of x. But since we're taking x to be a positive, very large positive number, we can just take it to be x. Remember that absolute value of x is just x when x is positive. Okay? So basically, mathematically, what I'm saying is take the square root of x squared plus 1. I want to have an x squared inside being multiplied so I can factor it out. So what I'm going to do is I'm going to factor out x squared out of both terms inside. So if I factor out an x squared out of the x squared, I get 1. If I factor out an x squared out of the 1, I get 1 over x squared. Remember that factoring is the same thing as I'm factoring out the x squared, it's the same as I'm dividing it out. Okay. So let me rewrite this so it looks more readable. Yeah. So factor out an x squared on the inside, that's what I get. Now, as I mentioned, since you can separate the square root into, whenever it's a product, you can separate it into each factor. This becomes square root of x squared, which is just x, again, because x is positive, times the square root of 1 plus 1 over x squared. And the reason for writing it like this is now it's going to be very easy to factor out the x. Right? Because what do we get? Well, we get that this equals, again, I haven't taken any limit, just rewriting things algebraically. I get x minus, I rewrote this, right, as x times the square root of 1 plus 1 over x squared. So now I can easily factor out the x. So I factor out the x, I get x, right? Now, the first term, I factor out an x, I get 1 left over. On the other one, I take this out, so I have square root of 1 plus 1 over x squared left over. Now, see that now we're closer to getting to the form in 1, 0 times infinity, because now we have a product. Now we have to verify that this is a product of the form 0 times infinity, so we can use the trick that we used in the previous video. Okay. So is it in that form? Well, let's check each limit separately. Let's go to another page for that. So right now we have the limit as x approaches infinity of x times 1 minus square root of 1 plus 1 over x squared. Hopefully this is in the form 0 times infinity. Okay. So if I separate this, what do I get? Well, the limit as x approaches infinity of x is just infinity, right? Times the limit as x approaches infinity of 1 minus square root of 1 plus 1 over x squared. So yeah, so let's verify. So as I mentioned, this one here is clearly infinity, right? We saw that one before. So hopefully the other one is 0. So let's see what happens. The limit of a constant is just itself, so that's 1. What's going on with this part here? Well, as x becomes really large, 1 over x squared is approaching 0, right? Because you have the numerator fixed, the denominator is growing very large, so this thing is going towards 0, right? So what is this whole thing? This thing looks like 1 minus 1 when you take the limit. 1 minus 1 is 0. So we have the right form. We have 0 times infinity. What does that mean? Now you can just go back and use the same trick that we did in the previous video. Now I'm not going to do everything, but I'm going to start you off. Like I mentioned, you want to use the term, you want to rewrite the term that looks the easiest to work with. What are the two terms here? We have x and this whole messy expression. So which one would you rewrite? Well, we recommend rewriting x. Okay, so just rewrite x as, what's the trick? 1 divided by 1 divided by whatever factor you have, which in this case is x. And then just as I mentioned, when you multiply everything out, after you plug this in, you should get the right form. And we can verify this. Right, so x I wrote as 1 divided by 1 divided by x. The rest I left the same. Okay. Now when I multiply this out, again, just multiply across, numerator times numerator. So on the top, I get 1 minus the square root of 1 plus 1 over x squared. And on the bottom, I get 1 divided by x. And here you can verify again that this is now an indeterminate of the right form, right? Because what happens here, if you take the limit of the top, well, we already saw that the limit of the top is 0, right? We saw it here. So we get 0 on the top. What happens on the bottom when we take the limit as x approaches infinity? Well, as before, the denominator is getting very large, right? Because it's x. The numerator 1 is staying fixed. So 1 over x is a fraction, is approaching 0. Okay? So now we have the right indeterminate, and you can just go ahead and apply L'Hopital's rule. So you can do that. You can finish it as an exercise, but that's the whole idea. So to recap, whenever you have something of the form infinity minus infinity, what you're going to do is, in general, look at the simplest term, because you're going to have something minus something. Look at the simplest one and factor that out of both terms. As you see, it might sometimes require a little bit of work to do that. But once you have that, you can get it as a product. You should hopefully have something that looks like 0 times infinity when you take the limits of each term in the product, of each factor in the product. And of course, since the problems we're going to give you, we're expecting you to be able to do them, they should work. Once you do this, you should be able to get something that looks like 0 times infinity. So that's the whole process, and that's the second type of problem, infinity minus infinity.